So we've been doing limits in terms of graphs of functions, and now we're going to look at them a little more algebraically. So I'm going to give you a function algebraically, and we're going to determine the limits. We got to copy down some of these rules, find these in your notes, copy these down. We got a constant rule, identity rule, so like the first one, constant rule. The limit as x approaches c of k equals k. That'd be like as the limit approaches x of c of 4, your answer would be 4. Identity rule, limit as x approaches c of x equals c. If you were to think about that in terms of the graph of x, you would look at as x approaches a number, it would be that number. And the coefficient rule kind of got chopped off down there at the bottom, but notice that b, taking the b out. So scribble those down and we'll slide on to the next one. And these are pretty self-explanatory. Sum rule, when you're finding the limit of two functions that you're adding together, it's like adding the two limits together. Same thing with the difference rule, same thing with the product rule, nothing too crazy there. Scribble those down. We'll look at them a little more precisely here in a little bit. Got the quotient rule. Quotient rule is similar to the other ones. If you want to find the limit of f of x over g of x, you're just going to find the limit of f of x divided by limit of g of x. And notice it says the limit of g of x cannot equal 0. That's important moving forward. We're going to talk about that a little bit later, but that's very important. That would be undefined. Power rule, if you want to take the limit out, you can take the n and raise the limit to the power. Same kind of deal. We'll look at that. Composition of functions, you did a lot of this probably as early as 8th grade. F of g of x, you'll take g of x and plug it into the f and all that kind of stuff. So I feel pretty confident you guys remember how to do that. When you find the limit, similar kind of stuff, you can do that and then kind of plug in your c. We'll do several of those examples today, but you can take the limit of g of x and then plug that into the f function. The root rule is just if you're finding the limit of a radical, then you can move that limit inside the radical and leave the nth root outside. And notice it says if the root on the right side exists. Sometimes with radicals, you got the imaginary numbers if you got a negative in there. So we'll talk about that here in a little while too. Substitution theorem. This is going to be one of our main talking points today. If f of x is a polynomial function or a rational function, then the limit as x approaches c of f of x is f of c. Hence the name substitution theorem. Provided that if f of x is a rational function, that the value of the denominator is not equal to 0. So if we got a rational function, anything that you can write as a fraction, as long as that denominator is not equal to 0, then we can do this. So which is a big ordeal in the upcoming lessons. So looking back at what you copied down in blue up top, we took that c and plugged it into the function. That's it. And most of the time that's fine and dandy. For the most part today, it's going to be fine and dandy. So scribble that down and we'll do some actual examples. So let's take this substitution theorem, try it out, see if it works. So we got limit as x approaches 2 of this quadratic function right here. I'm going to plug in that 2 squared minus 5 times 2 plus 4. Please excuse my dear Aunt Sally. That would be 2 squared would be 4 times 3 would be 12 minus 10 plus 4. I believe that is 6. So we got 6 right there. And over here, spoiler alert, told you the answer, equals 6. Why does that work? Why can I just plug that in? And why does that make sense? Looks like I was supposed to delete this, but I didn't. It's a quadratic function. The graph is a parabola. There won't be any holes in the graph. If you were to graph this thing, it would look like this. And you can see that as x approaches 2, so if you look at 2 on my x-axis down there on the right side, As x approaches 2 from the left side, it gets closer and closer to 6. As x approaches 2 from the right side, it's getting closer and closer to 6. Therefore, the limit as x approaches 2 would be 6. So graphically, we could see that. And going back to the point, it's a quadratic. It's continuous is a fancy word that we'll talk about in a little bit. But there's no holes in the graph. Like it doesn't chop up, and it's something that quadratic. You know what that looks like. There you go, 2, 6. So let's look at these. We're just going to plug these in as well. So plug in 2. The 2 cubed plus 1 over 2 plus 1. 2 cubed is 8 plus 1 is 9 over 3 equals 3. So if I were to graph that in Desmos, I would look at as x is approaching 2 and the y value would be approaching 3. Next one, plug in 4. 4 plus 4, that's cube root of 8. That's just 2. Limit as x approaches e. Ooh, so that would be natural log of e. 3 times e. Natural log of e is just 1. And let's just leave it like that. Don't tell anybody we left that down there in the denominator. All right, we got a sine function here. Limit as theta approaches pi over 6. So I'm going to plug in that pi over 6. That would be sine of 2 times pi over 6. So that would be the same as sine of 2 pi over 6 when I multiply, which is, let's write that out for everyone wondering. That would be the same as sine of pi over 3. And the sine of pi over 3 is right there. That would be 1/2 square root of 3 over 2. Sine is the y value. That would be square root of 3 over 2. Next, I've got the limit as x approaches 5 of this logarithm. So I got log base 3 of 5 plus 4. That's log base 3 of 9. That's just 2. Remember, this is like saying 3 to the x equals 9. So x equals 2. You can just write equals 2 right there. You don't have to do all that. Next one. As x approaches 10, same style of problem here. We got log base 5 of 8 times 10 plus 45. Sheesh. That is log base 5 of, that's 80 plus 45 is 125. That would be 5 to the what equals 125, just like we did up here. 5 to the x equals 125, and that is 3. All right, I want you to find this sheet of paper. It's got that on the top left. And we're going to just kind of work on those properties that we talked about to begin with. On all these, we just say limit as x approaches c. Limit as x approaches c. All these are approaching the same number. That's not really a big a deal. What we're looking for here is we're going to take 3 is the limit right here for f of x, and we're going to plug in 3. For g of x, the limit as x approaches c for g of x is -2. So I'm just going to plug that in, and then I'm going to apply all those rules from the first part of the video. All right. So I've got limit as x approaches c of f of x. So the limit as x approaches c of f of x is 3 times 5 times the limit as x approaches c of g of x. That would be -2. That would be 3 times -10. That's -30. Okay. Limit as x approaches c of this big square root here. So let's plug this stuff in. I've got 3 times the limit as x approaches c of h of x. That would be 4 minus 2 times the g of x. Limit is -2. This would be 12 plus 4 minus negative 4. That's square root of 16, that's 4. Okay, let's slide down. All right, we've got limit of f of x is 3, so that's going to be 3 squared. And then 4 minus the limit of g of x is negative 2. So this is like saying, what, 9 over 6? That reduces to 3 over 2. And this one, I've got the limit of h of x is 4 times parentheses f of x limit is 3 plus 6. So please excuse my dear Aunt Sally. 4 times 9, 36. Let's slide down. All right, got another square root. 2 times the limit of f of x is 4 minus 4 times the limit of g of x, which is negative 3. So this would be square root of 8, plus 12. 8 plus 12 is 20. That is 2 square roots of 5. Limit of f of x is 4 times parentheses g of x is negative 3 plus 5. That would be 2. This would be 8. Let's flip it over on the back. All right, we're given these two graphs right here. We got f of x right here and g of x right here. So what we're going to have to do is we're going to be given a limit for each of these, and we're going to have to go up to the graph and say, okay, here's the limit, and then we're going to plug it in down here. Okay, so this is the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 of g of x from the right, sorry. Okay, so from our rules earlier, we could write all this out if we wanted to. I don't want to, but I guess I'm going to have to. X approaches 3 from the right of f of x plus limit as x approaches 3 from the right of g of x. Okay, so that limit applies to both of those. You'll add them. So the limit as x approaches 3 from the right on f of x, I'm going to go to my graph of f of x, and then I'll look at x as it approaches 3 from the right. So from the right side, it approaches 6. So this one would be 6 plus limit as x approaches 3 from the right on g of x. So I'm going to look at this graph, g of x. So as we're approaching 3 from the right, it looks like it's getting closer and closer to 8. Okay, so we're getting closer and closer to 8 there. 6 plus 8 is 14. Okay. Let's slide down. Let's just do this one. Limit as x approaches negative 5 from the left. Okay, so once again, we could write this like this. I don't want to write it like this, but I'm going to. Negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. Okay, so let's find this. The limit as x approaches negative 5 from the left of f of x, as we're approaching negative 5 from the left, it looks like we're getting closer and closer to 3. Minus the limit as x approaches negative 5 from the left of g of x. So we'll come over here to g of x as we're approaching negative 5 here from the left. Looks like we're getting closer and closer to 4 up there. Is that right? 4. Answer is negative 1. Let's look at one over here. So this top one right here, it says limit as x approaches 3 of 4 times both of these multiplied. So instead of like rewriting it all out, I'm just gonna plug it in, okay? So we've got 4 times the limit as x approaches 3 of f of x. So let's look up here at f of x. What's the limit as x approaches 3? As x approaches 3, it looks like it's gonna be 6. Okay, looks like it's gonna be 6 times the limit as x approaches 3 of g of x. As x approaches 3 of g of x. Okay, so we're looking right here at x equals 3. From the left, it's getting closer to 1, but from the right, it's getting closer to 8. So that limit does not exist. Therefore, this whole thing does not exist. Okay? So I think that there's one more out of this set that does not exist. So when you're working through these, be careful of that one. Okay? Let's slide down here. All right, so we got some composition functions here. F of g of x. You know, if it didn't say limit right here, okay, if it didn't say limit, I would take g of x and just plug it into wherever I see an x up top in f, correct? So going back to our limit properties that we saw at the beginning of the video, that's what we're gonna do. We're gonna take g of x, plug it in up there, and go from there. I think that our note said that this is equal to, I think they wrote it like this, it would be f of limit of x approaches 2 of g of x. I think that that's how we wrote it, and that's okay, that's what we're gonna do. We're gonna find the limit of g of x and plug in up there. But I wanna write it out like this. So I've got g of x is negative 2x, and I'm gonna plug it in wherever I see an x up there. Make sure you write kind of small. So I've got negative 2x cubed minus negative 2x squared plus 4 times negative 2x minus 1. Okay? And I'm hoping that we can just substitute it in. It looks like we can. That shouldn't be a big deal. So I'm going to take this 2 and plug it into my g of x right there. Okay? So let's plug that in. So I've got negative 2 cubed minus negative 2 squared plus 4 negative 2 minus 1. And now it's just algebra from here. Thankfully, we had Miss Bruce, and we know how to do all this. So this would be, what, negative 4 cubed is negative 64 minus negative 4 squared is 16 plus, that's negative 4, this would be plus negative 16 minus 1. That's negative 32, negative 33, negative 97 is our answer. Man, that's ugly. All right, next one. We've got g of f of x. So I'm gonna take f of x, and whatever this is up here, this f of x, I'm gonna plug it in down here. So I'm gonna say negative 2. This is where my x would be, so I'm gonna take f of x and plug it in right here. So x cubed minus x squared plus 4x minus 1. And then I'm just going to take 2 and plug it in. So negative 2. This would be, what, 2 cubed minus 2 squared plus 4 times 2 minus 1. This would be negative 2. This would be 8 minus 4 plus 8 minus 1, and negative 22, is that right? Hopefully that's right. You can try those other ones. Last sheet. Let's look at this one. It's got all 4 graphs on it like this. 4 graphs on it. Okay, so we have a f of x up here, and h of x, g of x, and j of x right here. So going back to our notes that we just hinted at, this means f of the limit as x approaches 3 of g of x. Okay, so I'm going to find the limit as x approaches 3 of g of x, and then I'm going to throw it into the f function and see where it's at. Okay, so the limit as x approaches 3 of g of x, so let's look at g, that's right here. As x approaches 3, there's 3, looks like we're getting closer and closer to 1. Okay, so this would be f of 1. And then I'm going to go up to the f function. And f of 1 is -2. -2. Okay, let's try another one. Let's do this one. G of f of x. So this is like saying g of the limit as x approaches -1 of f of x. So let's find the limit as x approaches -1 of f of x. So as we're approaching -1 up here on f of x, looks like it's going to be -6. -6. So we're going to have g of -6, and when I get over here, g of -6, oh no, man. Well, since we got an arrow right here, so, -6 would be like over here somewhere. So it's going to be somewhere right here. I'm looking at this piecewise function. It's got a slope of down 2 over 1, down 2 over 1, down 2 over 1. All right, so I'm going to go down 2 and over 1. That would be for -5. -6 go down 2 and over 1 for -6. So that would be at what, -4, -5? Is it -5, 6, 7? Because we went down 2, right? I think it's -7. Last one, then I'm going to let you try the other ones. Let's look at this one. As x approaches 1 of f of g of x. So this is f of limit as x approaches 1 of g of x. So let's find the limit as x approaches 1 of this g function right here. As x approaches 1, there's a problem. From the left side, it's -1. From the right side, it's -3. So the limit as x approaches 1 does not exist. Therefore, this thing does not exist.